Here are your Chapter 3 notes, pages 4, 5, and 6. We'll start with the adding vectors practice problems. Question 1. One vector measures 3 meters in length. Another vector measures 5 meters in length. When added together, the two vectors cannot have a length of. This is based on a concept from geometry called the triangle sum theorem. If I take a vector that's 3 meters long and another vector that's 5 meters long, I'd like you to think about the longest possible distance that I can create. Oops. Let's grab my pen here. 3 and 5 would be 8. Now if I take those same two vectors and I add them in different directions, or if those vectors are going in different directions. So let's say here's my 5 and here's my 3. Now the resulting vector is only 2 units long. So anything between 2 and 8 is a possibility. But there's no way to add these vectors together and get 10 meters. Question 2. A vector has a horizontal component of 3 meters and a vertical component of -4 meters. Which of the following statements is not true? Before I attempt to answer this question, I'm going to sketch the situation. So I'm going to sketch a coordinate plane. And then I'm going to sketch my vector over 3 down 4. 1, 2, 3. 1, 2, 3, 4. There's my vector. The vector's terminal ray is in the 4th quadrant. That's true. The name of this vector, a vector is also a terminal ray, and it is in the 4th quadrant. So that's true. The vector's length is 5 meters. That's also true. If I were to do the Pythagorean theorem on this right triangle, I would see that it's a 3, 4, 5 right triangle. So that is also true. You can verify that with the Pythagorean theorem if you like. The vector's direction is between 270 and 360 degrees. That's true. 270 is straight down. 360 is what you get when you go all the way around the circle. So that's true. It leaves us with our last option. The vector's direction is north of east. That is false. North of east would be above this line, the positive x-axis. So D is our answer. Question 3. A vector has magnitude 10 meters and an angle of 30 degrees. Find the horizontal and vertical components of the vector. Here's a component problem that you can solve without a calculator if you remember your unit circle. Here I've got 10 meters at 30 degrees. You may recall for a 30, 60, 90 right triangle, the short leg is half the hypotenuse, making this 5 meters. And then the long leg would be 5 times the square root of 3. So my horizontal component would be 5 times the square root of 3 meters, and my vertical component of this displacement is 5 meters. By the way, I'm calling the 10 meters x. Question 4. As an angle of a vector increases from 0 to 90 degrees, the magnitude of the horizontal component. Again, I'm going to draw a sketch. I'm going to start out by drawing the coordinate plane. And I'm going to realize here that what I want to think about is what happens when I have a vector that starts out horizontal. If I keep the same length but increase my angle, what is happening to the horizontal component of that vector? What I'll do is I'll draw the horizontal component in red. Here's the horizontal component of my first vector. Here's the horizontal component of the second, the third. You can see what's happening is the horizontal component is decreasing. So my answer is B. Question 5. Joe walks 4 blocks east, then 5 blocks north to the library. What is the magnitude of Joe's displacement? Do not use a calculator to answer this question. Okay, I will sketch this. So, oops. Let's see if I can sketch that a little better. So 4 blocks east. 5 blocks north. Remember to add your vectors head to tail. Having a little trouble with my pen here. Hopefully you're doing better on your own. My resultant goes from, I'll draw it in a different color, the tail of my first vector to the head of my second vector. And all we want is the magnitude. All we want is r. I can solve this with the Pythagorean theorem. I can say that 4 squared plus 5 squared is equal to r squared. So 16 plus 25 is equal to r squared. 16 and 25 is 41. 41 is equal to r squared. And so r will be the square root of 41. And my unit in this problem is blocks. Okay, so that's page 4. Now let's take a look at page 5. We've learned the 4 basic kinematic equations for one-dimensional motion. And here they are. And now what we're going to do is we're going to apply them to a horizontal projectile. We're going to make some assumptions. In the vertical position, or in the vertical direction, a horizontal projectile behaves like a falling object with an initial velocity of 0 and an acceleration of negative 9.81. So what I've done here is I've taken our 4 kinematic equations, and VI is 0. So we're just crossing it out. And then acceleration is negative 9.81, which we sometimes call G. So I'm just making that replacement. And you'll see that's where I get the formulas on the left. Now in the in the horizontal direction, the velocity is constant. That is, an object does not accelerate in the horizontal direction. So let's do some sample problems. Example 1 on page 6. A projectile is launched with a speed of 20 meters per second from a height of 125 meters. Find the range of the projectile. Now the range is another name for the horizontal displacement. In order to solve this problem, I'm going to start by dividing my work into horizontal and vertical components. In the vertical direction, here's what I know. In the vertical direction, the initial velocity is 0. The acceleration is negative 9.81 meters per second squared. And what I'm going to be able to do is use the height. The change in height is negative 125 meters because it ends up below where it starts. I'm going to be able to use this information to find the time that the object is in the air. So I'm going to take my good old kinematic equation from chapter 2. You can use it in this form, or you can modify it and say this is vertical displacement. Initial velocity doesn't matter when you do 1/2 g delta t squared. And then I'll plug in what I know. I know that delta y is negative 125. The acceleration of gravity I think this is a problem that I can solve without a calculator. I'm going to use -10. Being a little lazy there, instead of using 9.81. So I have -125 equals -5t squared. Take a minute and try to do the mental math. -125 divided by -5 is 25. So I have 25 equals t squared. So t, the time in the air, is 5 seconds. Now, if the object is in the air for 5 seconds and it's got a horizontal speed of 20 meters per second, we can figure out how far it goes. And the horizontal, we can say that its horizontal speed is 20. And we know that it's in the air for 5 seconds. So we can figure out that its horizontal displacement is 20 meters per second times 5 seconds, or 100 meters. Question 2. Find the instantaneous final velocity of the projectile described in question 1. In order to find the instantaneous velocity, it's important to realize what's happening with this object. The object is launched with a horizontal velocity, but as it travels, at this instant, at the initial instant, it has a horizontal velocity, but think about what happens as it falls. It's going to hit the ground at an angle. And I'm interested in this velocity that it has the instant before it hits the ground. That velocity has two components. It has a horizontal component that I already know about. The horizontal component is the 20 meters per second. It also has a vertical component. It has been in the air for 5 seconds, and it's accelerating at -10 meters per second squared. If I multiply that, if I multiply acceleration times time, in this case, I will get the final vertical velocity. And I can see that the vertical component of the final velocity is -50 meters per second. Now it's just up to me to find this resultant, which I can do with the Pythagorean theorem, and then to get this angle, which I can get with inverse tangent. That's going to conclude this video because we're at 13 minutes. I'll see you next time.